It has become well known that, mathematically at least, time travel is possible. However, the materials needed to build a device that could transport humans through time are so exotic, we haven't even discovered them yet. But what if we told you there was another way? A way to peer into the past. So far back, in fact, that we could see the beginning of the universe. How those first few galaxies and stars formed after the Big Bang some 13.5 billion years ago. This is Dynamic Science, and in this video we're going to talk about one of NASA's most anticipated projects to date, the James Webb Space Telescope. It has taken over 20 years and $10 billion to develop. The James Webb Space Telescope, our very own time machine, is finally ready for deployment to put man's laws of physics to the real test by piecing together our past and fundamentally altering our understanding of the universe. After 7 years of delays, the Webb is finally prepared to launch on the 8th of December this year. The Ariane 5 rocket will launch the telescope into space, where it will then begin its 30-day, 1.5 million kilometer journey to the location of its orbit. Here, in between the Sun and the Earth at the L2 Lagrange point, it will take orbit around the Sun. The wings on the Webb are so large it will take a few weeks to unfold the origami-like hexagonal mirrors, to then begin its 5.5-year-long mission, which NASA is hopeful will continue for well over 10. We've all enjoyed the marvelous depictions of the universe that Hubble has brought to us over the years. So the question you might be wanting to ask is, what is so special about this telescope? Well, for starters, the Webb is a magnificent feat of engineering, with 18 hexagonal mirror segments, each 1.32 meters in diameter, weighing 20 kilograms and forming a primary mirror over 6 times larger and 100 times more powerful than Hubble, and yet lighter in weight, as the mirror segments are made from beryllium, which is both strong and light. The mirrors will reflect the light to the center, where a detector will collect and send the data to the scientific tools within. To avoid infrared radiation, false detections due to its own machinery, and to protect it from the heat radiating off the Sun, the Moon, the Earth, and any other large body of matter close by in our solar system, the telescope hides behind a 5-layered heat shield, which is 21 meters long, 14 meters wide, and is equipped with an advanced cooling mechanism called the cryocooler, which will be maintaining an internal operating temperature of an incomprehensible 6.7 Kelvin, or minus 266.5 degrees Celsius, on the verge of absolute zero. The James Webb Space Telescope is humanity's most powerful, having the ability to capture light from over 13.5 billion light years away. And since the observable universe is only 13.8 billion years old, hey presto, we have our time machine, enabling astronomers to peer back into the past merely some 300 million years after the Big Bang. The further in space scientists can look, the further back in time they will observe. The possibilities of the Webb are profound. We'll be finally able to collect data from the formation of the earliest stars, which previously had been prevented by dust clouds. We will be studying the formation patterns of the oldest galaxies, which will tell us a lot about why the universe exists in the state that it does. Many questions that have long been unanswered will finally see the infrared light of day. This powerful tool will allow us to study the compositions of exoplanets, find habitable zones, and possibly even discover life out there in distant space. Finally, we may have our fair chance of discovering an alien species and possibly study creatures of an unimagined biology. Carl Sagan would be very proud. Also, we will have a new angle to study black holes and further unravel the many mysteries surrounding these voids of space and time. Previously, we utilized X-rays, allowing us to measure phenomenon of extremely high temperatures that are so hot they emit great amounts of thermal radiation in the X-ray region, such as the accretion disks of black holes and the violent shredding of stars wandering too close to them. But now, with infrared capabilities, we'll be able to measure colder regions around black holes too, such as the planets revolving around the stars that are slowly being pulled towards them, telling us whether planets around black holes have the potential to support life of any kind and how long these planets survive. And of course, the chance of obtaining something completely unexpected is not only always there, it is always welcomed. Astronomers around the world have been waiting lifetimes for this event, which is scheduled for launch and able to be viewed worldwide on the 8th of December this year. So mark the date in your calendar and do not miss this historical event. Enjoying the content? Then shout us a coffee. And don't forget to like, share and subscribe to our channel for your weekly dose of dynamic science.